Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Warm-up 101's on the screen. Let's get started, please. All right, here we go. Number 1. It says, use -1, 1 to evaluate the functions f of x equals 2 to the x power and f of x equals 10 to the x power. Now, I'm introducing, I don't know if you noticed it was a little bit different. I'm introducing a new function that's coming up pretty soon, not next week, but the following. So this is some of the work that you're going to need to have already down. Here it goes. Evaluate. So what do I do, Mr. Q? That means I'm going to start with this one right here. I do f of 2 parentheses. So we're going to replace the x with these values. So what's my first value? My first value is -1. So f of -1 is 2 to the -1 power. Can we have a negative exponent? No, so that means this becomes 1 over 2 to the first power. And I'll leave it like that. Let's go to the next one. F of 2 parentheses. My next value is 0. What is 2 to the 0 exponent? Tell your neighbor, please. Everyone? 1. That is correct. And last but not least, f of +1. That is 2 to the first power. Any number to the first power is the number itself or the base. What is this base? 2. All right, so now that I did these, I want you to do f of x equals 10 to the x. Do that by yourself with all these three again, all these three values. All right, so f of -1, what'd you get for that one, Caleb? Help him out, JP. That is correct, 1 over 10 to the first power. Everyone, f to the 0 and f to the 1, 10. It's the base itself. All right, I'm going to stop right there. Once again, students, this is a new function. We're going to get there pretty soon. Numbers 2, 3, and 4 you should be able to do by yourself, but like I said, this is just extra practice to what's coming up. All right? Copy the agenda, please. Warm-up number 101, rational functions. Home plate pages 396, 397 only. Then get a Cornell note ready, please. All right, here we go. Our objective for today, I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. So what did we do these past days? We just graphed. Is that correct? Yes, Mr. Q. So today we're going to be adding a couple more components to that, which is writing and solving. However, what are rational functions? In your own words, tell your neighbor. By now you should know what they are. Rational functions in your own words. Rational functions in your own words. Let's see. Rational functions in your own words. Diego Rosa. Equations that contain fractions. Let's go. That is correct. Let's see. Here we have equations with a bunch of fractions. Yep, I got that. And then from there we talked about steps of what we did for the graphing portion. We got the vertical and horizontal asymptotes. We did an input-output table, and then we graphed. And today we have a couple more steps. Look up. You guys notice something different from yesterday to today? You guys see that? Your favorite long division? But we're not done. Oh no, we got to add some more steps. All right, get your phone, take a picture. So you're like, what? Take a picture just for the sake of time. You can copy those on your notes later on. I want to get to the practice portion so you can see the process at work. All right, bless you. So yeah, we're going to be doing two different things. The graphing portion is for the steps above, 1 through 4, and the writing of rational functions is down here. Okay? All right, so with that said, here we go. Oh my goodness. All right. So we have a general rule. We're done with the general rule. We got our asymptotes. We got that. We're getting closer to the diagonal, slant, and oblique. And then we talked about these, and we did some of this. Yes? Yes, Mr. Q? All right. Do me a favor. So on your paper, write this down. It's going to be a challenging one. Ready? Here it goes. 9 over 4. And we're going to use long division for that. Let's see if we know our process. Let me help you out. Here it goes. Tell your neighbor which number goes inside the little house. Yes, the 9. Very good. And the 4, which is the divisor, goes out here. So here we go. What number times 4 gives me a number close to 9? 2. So 2 times 4 is 8. Let's subtract. So 9 minus 8 is 1. That's my remainder. So what is my answer for that? The answer is 2 plus, what goes on top? 1 over 4. That is correct. All right. However, according to the commutative property of addition, look up to the screen, I am able to switch these numbers around. So that means I can send this one to the end and this one to the front. So I can switch it like this, and the value is the same. Do you agree with that? Some of you are like, I don't know, Mr. Q. Well, let me ask you, what is 4 plus 3? 7. What is 3 plus 4? 7. That's the commutative property of addition. That allows us to move stuff around. Today, some of you are like, oh, snap, Mr. Q, why are you showing us this? Well, because today, bless you, we're going to be doing stuff like this. Fairly simple, yeah? But with polynomials. Let's go. Yeah, because check this out. We know how to graph these. Is that correct? What do you guys notice? That the numerator is a what? A 1. So we need to make sure that we keep our form looking like this. However, today I'm going to give you some that look like this. Copy this one, example number 1. Example number 1. We got g of x equals 3x minus 4 over x minus 1. All right. So I don't know if you guys noticed. Do we have a 1 on the numerator? No. So to make it look like what we did yesterday, we need to use long division. So I start with my little house. There it is. Tell your neighbor what expression goes inside the house. Yeah, the 3x minus 4. And the divisor is x minus 1. All right, quick refresher. We've been doing a lot of synthetic division, but here goes long division. What number times x gives me 3x? 3, so that's 3. 3 times x is 3x. 3 times -1 is -3. What do we do there? We're subtracting, but remember what I taught you in the past? Circle that and distribute that here and here so that you don't forget. So with that said, 3x minus 3x cancel. What is -4 plus 3? -1, and that's our remainder. So what is our answer? Our answer is a big 3 plus a fraction. What goes on top? -1. And what's our divisor? X minus 1. Okay. However, according to commutative property, can we send the 3 backwards? Yes, so then we rewrite this. Now look up. I only need to have a 1 on the numerator. So what do I do with that negative, Mr. Q? You do this. Put it in the front of the fraction. This negative, we moved it to the front. We wrote 1 over x minus 1, and at the end plus 3, and this is our new function. Woo-wee! Let's go, Valente. All right, so from there, the rest is history. Let's start with our VA. X equals HA, Y equals. So by looking at it, tell your neighbor your VA and your HA. What's our VA and our HA? VA, hey, V for Valente. VA, what's our VA, Valente? Good, that's our HA. Let me write our HA right there. Close. 1, that is correct. All right, so now that we have that, let's plot those on our coordinate plane. Let me get that coordinate plane started. I'm going to graph it over here because I need space here for the work that we're going to do, and I'll show you that in a little bit. All right, so VA, we are at 1. HA is at 3. All right, so far so good. What would be our next step according to what we did yesterday? Oh, we start a what? A table. Yes, that is correct. However, for tonight, I don't want to make you work a lot. I just want 2 values only, 1 from each side. So tell your neighbor what values we're going to use for our table. We only need 2, 1 from each side. Here goes a hint. Let me highlight our VA. Tell your neighbor what values before I pick someone. All right. Tristeza. What values? 0 and 2, she said, and that is correct. 0 and 2. 0 and 2. Yep. So I'm going to write this right here next to the 0 so we can do the substitution. And I'm going to write it again for the 2. So here we go. My first value, 0. I'm going to go this way. All right, let's see. Negative. What is 0 minus 1? -1, okay, plus 3. So here, what is negative times a negative? Positive, 1 over 1, 1. 1 plus 3, 4. Next value, 2. Negative. What is 2 minus 1? 1 plus 3. So what is 1 over 1? 1 times a negative? Negative 1 plus 3? 2. All right, so let's plot those points. 0, 4. 0, 1, 2, 3, 4. And 2, 2. 2, 1, 2. Now, check this out. This is where I saw, earlier I was watching, or I was going through the home place, and some of the graphs, look up, you guys did some weird stuff. You guys pointed the graph towards this asymptote and this asymptote. Look up, like this. Some of you did this. That is incorrect. It cannot be pointing there or there. It has to point away from those. Away from those. So, what do? Whoa. Sorry. There you go. So we graph it away from that corner, like so. All right, from 1 to 5, I'll come to you with this. Yeah, we got this, right? So what is the only thing we do? Long division, send the constant to the end, make sure there's only a 1 on the numerator, find your VA, HA, pick 2 points, 1 from each side, and there's your graph. Let's do another one. Copy this. Example 1 cube. Example 1 cube. G of x equals 4x minus 7 over negative 2x plus 4. I'll give you a head start. Copy and go. All right, let's see. You should have written negative 2x plus 4 dividing into 4x minus 7, yes? So, what number times negative 2x gives me positive 4x? Negative 2, that is correct. So negative 2 times negative 2, that's positive 4x. Negative 2 times 4, that's negative 8. Subtract, and what did I ask you to do? Circle that, distribute that here and here. So, this cancels. 8 minus 7 is 1 as my remainder. So what is our answer? Negative 2 plus, what goes on top? 1 over negative 2x plus 4. Am I done? No, we send the constant to the back. So our new function is 1 over negative 2x plus 4 minus 2, and all that equals to g of x. And if you got something like that? All right. So from there we get to work. Here we go. VA x equals HA y equals. All right. Look up to the screen. Look at the denominator here. It's not as easy as getting our VA straight from there, but there's something that we need to do, right? Because there's that negative 2 there. So you never what to do from there. See if they remember to get our VA. Let's see, what do we do? Fabian. Right here, down here. Make it, let's go, Fabian, equal to 0 and solve. Minus 4 minus 4. We got negative 2x equals negative 4. Divide by negative 2. So x equals 2. That's our VA. Wow. And everyone, our HA is? Everyone? Negative 2, yes. All right, so let's plot those. Let me make my coordinate plane over here. All right, so we got negative 2 of y and negative 2, 1, 2. And positive 2 of x, 1, 2. All right. Not bad, not bad. How we doing? Good? All right. And of course, next we need to make our table, yes? X, g of x. Tell your neighbor the two values that we're going to use, see if they remember. What two values are we going to use for our table? All right, good conversation. Jose, go. Let's go. And once again, if you get lost, remember, highlight your VA and pick a point from the left and a point from the right. And we said 1 and 3. That is correct. So I'm going to write this 1 over negative 2, parentheses for x, plus 4 minus 2, going that way. And I'm going to write it again for the 3. Negative 2, parentheses, plus 4 minus 2. All right, here we go. Our first value is 1. So we got 1 over. What is negative 2 times 1? Negative 2 plus 4? 2. All right. So we have 1/2 minus 2. What is 1/2 minus 2, everyone? Negative 1.5. Yes, that is correct. Next value, 3. So we got 1 over. Here we go. Negative 2 times 3 is negative 6 plus 4, that's negative 2. So now we have a negative fraction and a negative number, so this is negative what? 2.5. Yes? So far so good? All right, let's plot those. 1 and negative 1.5. 1, negative 1.5. It's about right there. 3, negative 2.5. 3, negative 1, negative 2.5. And our graph. There you go. All right, from 1 to 5, I'll come for you with this. Yeah, 5 fours, 5 fours. Okay, let's do one more. We're not going to graph it. I just want you to rewrite the equation to the new g of x. So like that, we can have a 1 by itself on the numerator. Let's see what you get for that one. Example 1, super cube. We got g of x equals 3x plus 8 over x plus 2. All right, I'll give you a head start. Go. All right, check with your neighbors, see where they're at so far. Here it goes. I'm going to get started. I got 3x plus 8 divided by x plus 2. All right. What number times x gives us 3x? That's 3. 3 times x is 3x. 3 times 2 is 6. We're going to subtract, distribute. So this cancels. 8 minus 6 is 2. So far so good? Yeah. So your answer, you should have written 3 plus 2 on the numerator, x plus 2. Are we done? No. Send the constant to the end. However, look up. Do we have a 1 here? No. But isn't 2 the same as 2 times 1? Yes? So watch. I send the 3 to the end. X plus 2. And this 2, imagine that there is a 2 times 1. I'm going to send this to the front and leave the 1 by itself there, and move the 2 to the front like so. And this is our new g of x. Woo-wee! Let's go! Let's go! Does everybody understand this part? Yes? All right, and from there the rest is history. Tell your neighbor the VA. Diego, Romo. -2. And our HA, everyone, y equals 3. And the rest is history, yeah? All right, from 1 to 5, I'll come through you with these. Yeah, 5, 5, 5. Okay, let's crank it up a bit, yeah? This was the easy stuff. Come on now. Let's go. Copy this one. Example 2. Example 2. So, copy this graph. I'm going to give you some time to that, but let me show you the asymptotes. There's that one, the blue one. There's the red one. Give you some values. This is this is going through -2, and this one's going through 1. And from there, they only give you 1 point up here with these values, and 1 point down here with those values. So copy this graph, and then copy this general rule that they give us, and we'll go from there. I'll give you some time. Copy and go. All right, we good? All right, here we go. So for this portion, which is the last portion of your home plate, they're going to give you a graph. Here's a graph. And do you guys see a function graph here? Yes. And they're going to say, write the equation of this graph, given whatever form they give you. Here they give us this form. So that means we need to use this form to rewrite all of this. So here goes the process. We start off by identifying the form. Here it is. We got it. The next step, we need our VA and our HA. Tell your neighbor what those are, please. What is our VA and our HA? All right. What is our VA, Juan? -2. That is correct. It's right here. And our HA, everyone? 1. That is correct. It's right there. Okay. So far, so good. Which means I can substitute these values in here. So we know that our HA is K. Is that correct? So I write a 1 right there, right underneath the K. Which means our VA is our H. Is that correct? Yes. So instead of H, I write what? -2. Okay, so far so good. However, Mr. Q, I don't know what A is. Do we know what A does to any function, guys? It stretches or compresses. Do we know if it's going to stretch or compress? No, because they give us just some points. So, at this point, once you substitute these two, pick a point. Do they give us points? Yes, this one or this one. So which one do you want us to use, Frida? -1, -3. Okay, so we're going to use this point. So I'm going to label this X. And this one, instead of Y, is what? G of X. So now we have values to substitute in here. So instead of G of X, I'm going to substitute -3. And instead of X, I'm going to substitute -1. So let me zoom in to that portion. Here we go. So let me rewrite this. So I got -3 equals a 1 over my negative sign, which is this one. And what did we substitute for x? We substituted -1 What did we substitute for h? Negative 2. And all of that plus 1. All right, from there on, I'm going to solve for a. I'm no longer going to use colors. I just showed you the colors so you can see the substitution. So here we go. Negative 3 equals a. Let's see. 1 over. What is negative times a negative? Positive. What is 2 minus 1? 1. And at the end, plus 1. Okay. What is 1 over 1? Times a. A. Bring down the plus 1. And then we solve for a. How do we solve for a, everyone? Subtract 1, subtract 1. So negative 4 equals a. So, do we have now enough information to write our function for this graph? Yes, Mr. Q, let me zoom out. Here we go. So, I'm going to take this form that they gave me and just follow it using the values that we have. What values do we have? We have the VA, the HA, and our A. So, I write G of X equals, done. What goes next? Negative 4, yes. Parentheses. 1 over X minus, what is H, everyone? Negative 2. And what is K? Plus 1. What is negative times a negative in here? And this is our equation. Ooh-wee. Let's go, let's go. Oh yeah, we got this. From 1 to 5, how comfortable are you with this? 5 fours, 5 fours, okay. All right. So, with that said, copy that one. See if you can do that one by yourself completely. Let me show you the asymptotes. Here's the red one. Here's the blue one. This is 1, 2, 3. This is 4. This is 1, 2. This is 3. And my points here and here. All right? See if you can do that one by yourself. Copy and go. All right. Should be just about done, yes? See if I can do this in my noodle. We got 4. We got 3. 4. So the last part of our, the last part should be, let's see, G of X equals something minus 3 plus 4. So far so good, yeah? And I just need, here's my X. I just need A. So what point did you use for that one, Anaya? 2, 2, yeah? Makes it a lot easier. So you would substitute 2 there and 2 there. So 2 minus 3 is negative 1. So this would be 2 equals A times negative 1 is negative A plus 4, sorry. So minus 4, that's negative 2 equals negative A. So 2 equals A. So that goes right there. Hands if you got that. Let's go, let's go. And I'll stop right there. Once again, your home plate is up on Canvas. Have a good one, guys. See you guys tomorrow. Bye.